Okay, today we're going to deal with changes to the function rule. This is going to be Chapter 9, Section 3. We've already dealt with, this isn't out of Chapter 9, but we've already dealt with stuff that looks like this. And we dealt with the changes to this rule. But now what we're going to do is we're going to actually make our changes here. So just to reevaluate what all the letters mean, A is your vertical stretch or compression. It also reflects across the x-axis if it's negative. B is your horizontal stretch or compression, and it'll reflect across the y-axis. H is your movement left and right, and remember that it's minus h, so if this is plus 3, then it's really going 3 to the left. If it's minus 3, it's really going 3 to the right. K is your movement up and down. Well, we're going to have very similar rules, so I'll start off with the easy ones. The difference here is our changes are going to be to the actual function rule. It's going to say something like this. So what does this mean? This is inside of parentheses, just like this is. So this is our h value, so it's going to be x minus h. So what changed here? Well, it's minus negative 3, which means it's 3 units to the left. We can also have values that tell us something like this. This is on the outside of the parentheses, just like the k is here. So what this is going to do is it's going to be plus k, which means that we're going to go 3 units up. Those are very similar to what we've done before. Okay, so not a big change here. What's kind of a little bit of a change is something like this. What this is telling me is that it's reflected across the y-axis. This is the same thing as my b value before. It's inside of the parentheses, so it's b, so it's the same thing as 1 over bx. Well, remember, if b is negative, then it's reflected across the y-axis. So this is reflected across the y-axis. If they want to reflect it across the x-axis, we'll put it in front of the function rule. This is like the a value. The a value is going to be in front of the whole entire rule. So if we have something like this, then it's going to be, when the a is negative, it's going to be reflected across the x-axis. And then you have stretch and compression. So if I give you something like 3f of x plus 2 minus 4. Well, I have 3 things happening here. I have an a value, I have an h value, and I have a k value. The h value is going to move me 2 units left. The k value is going to move me 4 units down. The a value is going to vertically stretch me by a factor of 3. So these are the same things that we dealt with before, only we're making changes to the f of x and not to the other side of the function rule. So that's the big difference here. Okay, so there's not a huge difference. Just instead of changing the rule like we did before, we're going to look at what it's telling us to do to the function rule. Now, why would we do this? Well, we'll do this for piecewise functions and stuff like that. So instead of changing every single piece of the piecewise function, we just say, here's the transformation here. Now you do that on your piecewise function that you already have. Okay, do a couple more examples really fast. Okay, I have a few different things happening here. I have an a value, I have a b value, I have an h value, and I have a k value. Now remember, your b value actually needs to be factored outside of a second set of parentheses. So I'm going to make this 4 times x plus 2. The reason that I do that is my h value is not actually 8. It's not actually negative 8, it's negative 2. So we need to actually factor it out when we have a b value in there. Now remember, it's 1 over b. So 1 over b equals 4, which means that b equals 1/4. So this is going to be a horizontal compression. Okay, so the negative right here is going to reflect this across the x-axis. The 4 here is going to horizontally compress us by a factor of 4. The 2 here is going to move us 2 units to the left, and the 9 here is going to move us 9 units down. And that's the answer. Okay, I have a couple different things happening here. I have a b value, an h value, and a k value. Remember, anytime I have a b, I have to factor it out, so this is going to become 1/8 x minus. When I divide 16 by 1 over 8, that's the same thing as multiplying by 8. So 16 times 8, 128. So the 1/8, this is 1 over b, which means that b equals 8. That number is larger than 1, so that means that this is a horizontal stretch by a factor of, and you can put 8 or 1/8, I'm going to put 1/8. This means that I moved 128 units to the right, and this means I moved 1 unit down. And that's it. So very, very similar to the stuff that we've already done. The difference is that we're doing it to the f of x side now instead of to the other side. Okay, so let's look at the overall rule. The overall rule is a f 1 over b x minus h plus k. Let's say that they gave me something like f of x equals x squared minus 9, x plus 2, and then this is x is less than 0, and this is x is greater than or equal to 0, okay? They give me this function rule and they tell me to do a translation of 3f of x. Well, what this means is I'm going to multiply this whole entire deal by 3. If it's happening to the f of x, if it's an a, it's getting multiplied by the whole entire deal. So that means that I'm going to multiply both of these parts right here times 3. So I'm going to get f of x equals, when I multiply this by 3, it gives me 3x squared. When I multiply this by 3, it gives me 27. When I multiply this by 3, it gives me 3x. When I multiply this by 3, it gives me 6. The rules still stay the same. So no change there. So that's what happens with the a value. The a value is multiplied by everything. Well, notice that the b value is inside of parentheses. So since the b value is inside of parentheses, that means when if I have a b value, it's only getting multiplied by these guys in here. It's not getting multiplied by this guy out here, which this would be a k. So this is not going to get multiplied if that happens. So let's use the same rule, and let's say I have f of 3x. Well, that means that the part inside the parentheses right here is getting multiplied by 3, because that's my b value. Well, my b is really 1 over 3. So I'm going to multiply by that. So that means just this part right here is going to be multiplied by the 3. Okay? So I'm going to do f of x. Oops, forgot my function rule. So just this part right here gets multiplied. And on this one, just that part gets multiplied. So notice that the negative 9 and the 2 don't change. So because the b value is inside of parentheses, it only gets multiplied by the x values. Okay? Now the h. What is the h being added and subtracted to? Well, keep in mind that it's moving it over, so it's inside of parentheses as well. So if they gave me something like, that means that they want me to move every x value 3 units to the right. Well, how do I do that? It needs to be inside of parentheses here. So this guy right here is going to become x minus 3 squared. It's just a replacement, like how we've been doing before. So f of x minus 3 means that the x is replaced with x minus 3. The minus 9 stays the same. And this one, it's going to be x minus 3. Now obviously this is a linear equation, so you could combine these two and just put as x minus 1. But either one's fine. Okay, this is showing me that you actually did it. This would be the final answer. Either one is totally fine. Okay, so when you have something like this, it's just replacing the x value. So your h replaces x value. You could expand this as well, but I don't need you to. Okay? Now the k is just being added at the end. So if they gave me something like, that means that I'm just adding 3 to whatever's at the end. So on this one right here, it's going to be x squared minus 9 plus 3 is minus 6. X plus 2 plus 3 is x plus 5. And I would still have the same restrictions, but I don't really have room here. So that's what we're looking at, these guys. So this guy gets added on the end. And that's it. That's how you deal with each of these, okay?